Alrighty, hello there algebra students. Today we're going to be going over a very detailed and very slow process on how to solve a problem featuring the product of power rule. Product of power rule, as you recall from class, is if you have a base raised to an exponent and you multiply it by that same base raised to another exponent, the way that you resolve it and the way that you get rid of that redundant base is you just take the original base and you add the exponents. You're just going to be adding the exponents. You take the exponents as they're written down, exactly as they're written down. If there's a negative number, you keep it there. You're going to take it, you're going to put it where the A is. You're going to take the B, you're going to put it where the B is. No matter what is written there, worry about signs, worry about arithmetic, worry about any operation you want after you copy it over. There are so many errors that are made by trying to second guess the process and second guess what the rule is and what the rule asks for. All you have to do is add A and B together. A and B exactly as they appear in the problem. So I'm actually going to solve this problem two different ways. And if you need to pause or go back or watch me solve it one of the two ways, by all means, that's what the video is for. But we're going to start with the product of power rule and then move on to some of the other rules. So with this first part, this looks intimidating because now we have to worry about parentheses. Now with parentheses you think, what about the order of operation? And that's the thing. The way the parentheses are written, it's just multiplication. It's still just multiplication, but it looks bad because it's parentheses. This is absolutely no different from any other problem that we have done up to this point. So in this case, well, I'm going to rewrite it the exact same way that I rewrite the other problems, but we're going to take our time with it. Now, the top statement and the bottom statement are the exact same thing, mathematically speaking, of course. All of these inside the parentheses are multiplied with one another. These are multiplied together, these are multiplied together. Because everything is multiplication, because this one big equation is all multiplication, I can break it apart like this and put together the parts that I want to solve first. So I'm choosing, by convention, and by habit if I'm being honest, I'm going to start with the whole numbers. So with this one, I have 2 times 7. Hopefully I don't have to go too far in depth as to what we're doing with that. We got 14. The integers are taken care of. Next part, got a little noise from outside. Next part, I'm going to have to deal with the h's. There are two different ways that we're going to solve for the variables, but they break down to the exact same method, just different ways of doing the same method. The first method, like I said, I'm going to take my time with, is going to be using the product of power rule as it is right now. And what I'm going to do is I'm going to pick the first two here. I could pick this one and this one. I could pick this one and this one. All I'm doing is I'm picking 2 and I'm going to plug them directly into the product of power rule. So again, I'm going to start with the first 2, 3, and 4. So again, I've got my base raised to an exponent, like with the power rule. I'm multiplying it by the same base, and the base is base, for reference, is the number that's being raised to the power. The same base raised to another power. The whole purpose with the product of power rule, again, is to get rid of the fact that I've got two of these. I only need one. So that one is going to be over here, and I'm going to take these two numbers exactly as they appear, and I'm going to add them together. I'm going to add them together eventually. You got me. What I'm going to do first is I'm going to write them down as they appear. I'm not going to do anything with the operations yet. I'm taking the 3, putting it in the 3, then I'm taking the 4, and it is plus 4. I'm taking, it would be the exact same thing regardless of what the 4 was or what was going on with the 4. It would be 3 plus 4, which is going to give me h to the 7. 3 plus 4, 7. Hopefully we're all on the same page with that. Now I'm not done with the h's, because it's like I've got this one taken care of, I've got this one taken care of, but I've got this one right here. Now if you remember, I mentioned in class, if you have a variable that's just hanging out on its own, it's minding its own business, it's not doing anything, for the purposes of our rule, we get to assume that it has a little 1 there. So it does have an exponent, it does have something we can plug into the rule. So I took care of these two first. So what I'm going to do is I'm going to take the 7 that came from these two, I'm going to take this answer, h to the 7, that came from these two, and I'm going to plug it in to the same product of power rule with this one. So again, start with a base, raised to an exponent, as we see here, multiplied by the same base, raised to another exponent, so as we have here, that's going to give us 1 of the base, and we're just going to take 7 plus, I'm just going to take at whatever is written here, as it is written, 1, which will give me h to the 8. The reason that I wrote down h to the 8 over there is because that is the final simplified answer for the letter h. There is nothing else that we can do there's nothing else that we can do in order to simplify it, in order to expand it. It's done. We started out with 3, we needed 1. So we applied the product of power rule twice. And each time we applied it, we took one of the h's down. So, applying it twice, we got rid of 2 of them, leaves us with h to the 8. All of the exponents are accounted for, all the variables are accounted for, all the exponents are accounted for with this variable. We are good to go with h. Now, mentioned earlier, again I'm going to pause here. If you need to write this down or record it, pause now, because I need the space. And the eraser. What I'm going to do now is an extension of the product of power rule. The more astute of you have noticed that I have x to the a times x to the b equals a plus b. But they're unified by multiplication. If it's multiplied on this side, it's added on this side. Does that mean I can have this? Can I have x to the a times x to the b times x to the c? Yes, you can, because it is the exact same operation. And on this side, it is a plus b plus c. If you want to take it farther, you can add x's as much as you want, because all you're doing to get rid of the extra x's is you are adding all of the exponents. You're adding all of these little numbers together. And as long as you add these numbers together, you can get rid of as many bases as you want, provided they're the same base. So I got 3 S's. By George. Because I'm using the product of power rule again, I'm taking a base times a base times a base. That means that on the other side of the equal sign, I'm just solving for one of the bases. Now I'm going to take, again, I'm going to just look at the exponent, and I'm going to copy the exponent over as it appears. 2 plus 6 plus 4. The product of power rule, you're adding the exponents together. All I did was I just copied 2 over, 6 over, 4 over. And they're all united together with addition. Which will give me s to the 8th is 12, there we go. Which will give me s to the 12. That is the simplified expression. I don't have any more s's. I don't have anything else I can do with s. So, I'm going to move back over to the winner circle. If you're doing these problems the way that I'm demonstrating, the problem itself will be simplified when you finish up each variable. If you have all 3 of these as simplified components, you have a simplified answer already. So all I'm going to do is I'm going to combine them together. As they are right here, you're in pretty good shape, but you're not done with the problem yet. We've got to get rid of these multiplication signs. So we're just going to clean it up and get rid of those multiplication signs. It's 14, there we go, 14h8 s to the 12. There is absolutely nothing different between this one and this one, except this is the proper final answer. This is the fully simplified answer, and this still has the multiplication separating them. It is crucially important that you get each element separated and that you know which elements are going into which rule in order to get a simplified answer. In this case, could I have looked through here and said, okay, I see a 2 and a 7, that's a 14, put a 14 there. I'm looking at the h's, I see 3 plus 4 plus 1, that gives me 8, I'm looking at the s's. Could you do it that quickly? Could you do it that way? Absolutely. And if you can do it that quickly, if you can do it that way, I'm obviously not going to stop you. But until you can track that many things, until you have the kind of practice where you can rely on that sort of shorthand, the best way to get a guaranteed correct answer is to break it apart exactly the way that I showed you. Take the components apart, put the like terms together, and then work one step at a time. You are never going to be in a situation where you have to get things done quickly, and this will not do it. You follow this procedure, you will get a correct answer. Now, moment for pause for flash photography. We're going to do a couple variations of this problem. Not of this problem specifically, but of other problems. And show you different ways of how we're going to resolve them and different systems. Whoops. Got a little overzealous there. All right. So, what happens if we have negative exponents? What do we do if we have a negative exponent with with one of our variables? Let's take a look. All right, this is actually going to be 2 birds with 1 stone. When you take a look at a problem like this, you should still have the exact same instincts. You should say, I'm going to take apart the parts that belong together, and I'm going to take apart the parts that, and I'm going to separate them out with the other parts that belong together. So in this case, I only have the one variable x, which is fine, because it doesn't matter, because I'm going to show you how to deal with negative exponents and what to do with the power rule with negative exponents, and there's no reason to make it more complicated since all we're going to be doing is demonstrating this rule. So I'm going to take the numbers, I'm going to put them on the far left, and then I'm going to put the x's on the far right. All right. What I'm going to do, I mentioned we did it earlier with the problem where you could do x times x to the a times x to the b times x to the c, and you can solve them all at the exact same time. I'm not going to do it that way. I'm going to solve them 2 at a time in order to give you as much exposure to what to do with negative signs in the exponents as you can. So as we start here, I've already separated out the coefficients, which are the big numbers, the big integers, and I've separated out the x's. I'm going to take care of the integers first. All right, that didn't take long. Now I'm going to deal with the x variables. I'm only going to do them 2 at a time. I could do them 3 at a time like I did with the s's in the previous problem, but again, I want to show you as many different times as I can how to deal with the negative exponents. So all I've done is I'm going to be working with these 2 first. X to the negative squared and x to the 6th. Negative squared, x to the 6th. I'm getting rid of one of these base variables by doing the product of power rule. And as I've mentioned before, all you do is you take them exactly as they're written, and you add them together like with the formula. That's all you do. So in this case, the first one is written to the negative 2. So x to the negative 2 plus, notice I put the operation down there first because it doesn't matter what is happening with anything else. All that matters is that you copy the numbers over exactly as they're written. 6 is in the B spot. So I've got negative 2 plus 6. Now that I have it written down, now that I have the negative and positive signs worked out, I can see that this is equal to x to the 4th. All right. Now I'm going to do what I did with the h's before. These 2 give me x to the 4th. Now I'm going to move this one over, and I'm going to do the same product of power rule, and I'm going to incorporate this last, x to the minus 3rd. Now again, I've got a base raised to a power times the same base raised to another power. In using these rules, I am eliminating bases so that the equation becomes simpler. So x, now again, I'm just going to copy the numbers down exactly as I see them. X to the 4 plus, again, nothing else matters. It doesn't matter at this point. X to the 4 is the first term, that's the a. Plus is the operation. It is always going to be plus. It is always going to be plus at this stage. The second exponent, though, is going to be negative 3. That's fine. So do you see what I mean when I say you're just copying them down as they appear? I've got x to the 4th, wrote it down exactly as it appears, plus, because that's the rule, that's the operation we're doing, x to the minus 3, minus 3. Now that it's written in this form, now that it's written this way, I can simplify it out. X to the 4 minus 3, which is going to give me x to the 1. I'm going to move back over here because I'm done. I've done the product of power rule. I've simplified my bases. I know that I'm going to end up with x to the 1. Now we just have one more step to do before this is completely finished. By mathematical convention, if you have an x raised to the first power written the way that it is, all you're going to do is take away the 1. It's assumed and understood that x to the first power just equals x. And in order to fully simplify the problem, that's what you got to do. So I'm going to get rid of this multiplication sign. And I'm going to get rid of the exponent. But this is going to be your 100% simplified correct answer. Because, as I mentioned verbally, but I'll write it down here, x to the 1 equals x. If you remember from the previous problem, we had h on its own, minding its own business, and we said that we assumed h had a 1 in the exponent. This is the exact same thing. In order to solve the problem, in order to do the rule, we're adding a 1 to the unoccupied x. Or in the previous problem's case, the h. Now that we're done solving the problem, we don't need that 1 anymore, so off it goes. It is important to remember part of your identities that you need to keep in mind. X to the 1 is the exact same thing as x on its own. What I'm going to do one last problem where I'm going to show a different identity, but I'm going to solve it the exact same way, just to kind of give you the practice. But it's going to be you'll see. We're still just using the product of power rule, because that is the only procedure I want to review with you in this video right now. So first we need a problem. There we go. That's all we need to demonstrate this next point. So I've got 8x to the 4th times 4x to the minus 4th. Some of you that are working ahead of me are thinking, hey, wait a second, what's going on here? Don't worry, we'll catch up to you in a second. Let's start out by breaking apart the problem by combining like terms. I need to see this on your worksheets that you're breaking things apart. Until you can do this in your head consistently, and consistently is pretty much the best word, until you can do this in your head consistently, I need to see that you understand the process and you understand what each of the steps requires. So again, I'm breaking apart the problem. It's still paragraphs. Long day, huh? I need to do the shooting schedule on weekends like I used to, but it's all parentheses. Because it's all parentheses, it's all multiplication. Because it's all multiplication, again, I can rearrange the terms however I need to. So in this case, I have the 8 and the 4 together, I've got the x's together. I'm just going to go ahead and knock out the 8 and the 4. Now, I'm going to take the x, and I'm going to take these two x's, and I'm going to apply the product of power rule. I am applying the product of power rule again. I have a base raised to a power multiplied by the same base raised to another power. The goal of the product of power rule is to get rid of as many extra variables as we can. So, I have x on the other side of the equation. As I've mentioned several times before with this video and with other problems, Right now, all you need to do is write things down. You don't need to think, you don't need to process, you don't need to step ahead. You just need to write down exactly as they appear. So first it's x to the a times x to the b equals x to the a plus b. So x to the a in this case is 4, plus, I just wrote plus, it doesn't matter, I just wrote plus, that's because that's the operation for the rule. I'm just writing plus, just a simple writing, just a simple rote memorization, just writing it. And then b minus 4. I'm writing it exactly as minus 4. Now that I have it in this form, now that I've got all of the exponents combined together, or ready to be combined together, it's just an integer operation. So let's work with that integer operation. That's going to give me 4 minus 4, because if you add a negative, you're basically subtracting the positive again. And that's going to give me x to the 0. Uh-oh. What does it mean to be x to the 0? If you run into x to the 0, or if you run into any variable to the 0 power, all you need to remember is that x to the 0, or any number raised to the 0 power, any number, any constant, any variable, any base raised to the 0 power is just going to equal 1. That's it. Base raised to 0 is going to equal 1. So what does that mean for our answer? It means that x has been completely eliminated from the equation. We no longer have to deal with x, because if I take the results, which is 1, and I move it over to the winner's circle, that gives me 32 times 1. In order to simplify this, I have to combine these terms together somehow. If you have 32, if you have any number, multiplying it by 1, you just keep the number. So the fully simplified answer for this equation is going to be 32. So, walk through it one more time. I start out with everything united under multiplication. Looks, even though it's parentheses, it's still multiplication. I'm moving all the like terms over to this side. Now, I'm moving those terms over there. I'm moving the x's over here. Taking care of the 8 and the 4 first, because that's the easiest to do. I take care of the x's next. I start out putting them into the formula. X to the a times x to the b equals a plus b. X to the a is 4 plus x to the b minus 4. Just a direct copy-paste, rote writing, no thought, just 4 plus minus 4 there. Now that it's written down, I can make the corrections that I need in order to make the integer operation easier. So plus a negative turns it into a minus. X to the 4 minus 4 is x to the 0. X to the 0 equals 1. Any number raised to the 0 equals 1. Move it, so I'm going to move my solution over again to the winner's circle, showing that the answer is simplified. And I have 32 times 1, which is itself only 32. Now these have been some pretty significant examples for the product of power rule, but it really just breaks down to that same process that I talked about earlier. If you stick with the process, if you trust the process, you will get the correct answer every single time. It's important, once you start getting the correct answer every single time, you'll start believing in yourself. You'll start believing that you can do these equations, that you can solve these equations, and frankly, you'll be able to. And you'll be able to do as well as I know you can do. You just, if you don't trust yourself yet, trust the process. Until you trust yourself, you got to be able to get the right answer. So, that is how we're going to do it, and that is a very, very granular look at the process for product of power. The next videos we're going to go over are the quotient of power rule and then the power of power rule. And that should get you set up for the first assessment. But again, product of power rule, x to the a times x to the b. All you do is you add the exponents and get rid of one of the x's.